Yesterday, you completed an activity to let you explore a little bit about translations. So we already introduced the fact that a translation slides a shape. So you were looking at sliding a triangle around on a graph in yesterday's activity. So one thing that you may or may not have been paying attention to in your activity, but when you were sliding that triangle around and moving it to different places on the graph yesterday, no matter where you moved that triangle, it was still the same triangle. So sliding the triangle did not cause it to suddenly morph into a different triangle or a different shape, did not cause it to get bigger or smaller. It was still the exact same triangle, just in a different spot. So when you translate or slide a shape, it will always create a congruent figure. Since we've been talking a little bit about congruent versus similar, that is a connecting piece with what we've been talking about and what we're now talking about with transformations. So a translation creates congruent figures. What we're going to do is take a few minutes in today's notes and summarize some ideas that you got introduced to when you were experimenting with translations in yesterday's activity. First of all, I want to take a minute and introduce you to notation for something called a transformation rule. And this notation we are going to be using with all of our transformations, translations, reflections, rotations, and dilations, all four of the different types that we're going to look at. Since we haven't worked with it yet, we're going to take a minute and talk about it now. What a transformation rule does is it uses algebraic expressions to describe how the points on a graph are moving. So basically, it gives an algebraic expression that tells me if I do this to the pre-image points, I end up with the image points. And it uses a predictable format. So this part of the notation always looks exactly the same. So this is the part that represents the pre-image. So it's basically XY is generic, saying whatever your pre-image points are. And then this arrow is the symbol for a transformation. So it's basically telling you, do this to your original pre-image points. And then what follows is kind of like, it looks like an ordered pair, but instead of numbers in it, it has expressions in it. So this is going to be the expression that tells us how to change the x coordinates. So expression for x. And then the second part, instead of having a number, there's going to be another algebraic expression, and it's going to be the expression for y that tells us what to do to the y coordinates to get the new coordinate. So we're actually going to look at this notation in just a minute in terms of a translation, so you'll get to see what it actually looks like being used, and it'll make a little more sense. But you're going to see this notation in all of the different things we're working with, and you're going to see this notation show up in your assignments, which is why I wanted to introduce it to you. It's a notation you should be familiar with. So to summarize translations, at the end of the translation activity yesterday, you were asked to make some observations about how the shape was moving and how that connected to the coordinates. So if you look back at your work, so you were asked to do some things to coordinates. So you were asked to add or subtract from the x coordinates and add or subtract from the y coordinates. And then you had to look and see, okay, what did those changes do to the shape? So looking back, if you were correct in your conclusion, so you should have noticed that when you added to the x coordinates, that made the shape move to the right. Subtracting from the x coordinates makes the shape move to the left, which makes sense because the x-axis runs side to side, so it makes sense that it would control movement left and right. Adding to the y coordinates, you should have noticed, moves the shape up, and subtracting moves the shape down, which again makes sense because the y-axis runs up and down, so it makes total sense that that would control movement of the shape up or down. So knowing that, we can use that in combination with this transformation rule outline that we just introduced to actually write and use some transformation rules for translations. So a couple of examples of things you should be able to do at this point. So you should be able to take a shape that's already been translated on a graph. So you can see this graph, we have a couple of trapezoids. So first of all, we need to remember our notation from yesterday. We talked about prime notation and how that lets us tell the pre-image and the image apart. So you can see the top shape has that prime notation. So that means that's our ending shape. So this is the pre-image, or the shape before the movement. And this is the image, or the shape after the movement. And we could tell that because it's got those little apostrophe marks on it that we said we put on the shape after we moved it. And that's exactly why we do that, because now we can look at this and tell which shape was the starting shape and which shape was the ending shape. So what this is asking, it says write a rule for the translation. So if we're writing a rule, whenever you see that write a rule, you should automatically be thinking about this outline notation. So we said the first part of all rules start the same, and it's basically the generic thing that says take the starting coordinates, whatever they are, and do this. So that part stays the same. But now what we have to fill in is what we're actually doing to x and y. So if we look at our coordinates on this graph, we can see, so if we look at the matching coordinates, so to get from m to m prime, I have to go up and then to the right. And you'll see that that happens with all the coordinates. L, I also have to go up and to the right. So up and to the right. So you can see that happening with all the coordinates. So it also happened with O and with N. So we know we're going up and to the right. So up, if we look back at our observations, up we can make happen by adding to the y coordinate. So we just have to look and see how far up we're going. So we're starting down here at, so -4, if we look at like point L, they all move the same amount. So -4, and we're ending at 3. So that's moving up by 7. So if we want to go up 7, that means we have to add 7 to y. So that's the expression that would tell us what to do to the coordinates to make the shape move up. Now the shape also moved to the right. So we have to look and see how far to the right did the shape move. Well, if we look at all of our points, we can see that all of our points are shifted over 5 to the right from where they were before. So since we are going to the right, we know that adding to x moves us right. So if we moved over 5 to the right, then the way we could show that in our rule would be to add 5 to x. So x plus 5. So that is the rule in correct notation that matches what happened on the graph with this translation. So you should be able to take a translation off of a graph and tell me the rule in notation that would make the shape end up in that place. You should also be able to reverse this. So if you have a rule that's already written, you should be able to tell me how is that going to move the shape. So if I look at this rule down here, x minus 6 and y plus 5. Well, if I look, x minus 6, that is subtracting from x. So that's going to move us left. Since we're subtracting 6, it's going to move us left 6. So this part is going to make the shape move left 6. And then, and we're also doing something to the y. So that's going to make the shape move as well. We're adding to the y. So if we add to y, that's right there, adding y, that's going to make the shape move up. Since we're adding 5, that means the shape is moving up 5. So this rule is telling me that I am going to translate or slide my shape left 6 and up 5. So that gives you a summary of translations and an introduction to writing a translation rule, and also connecting adding and subtracting to how the shape moves. You should have your example all your notes all filled out at this point. when you're ready, you have a short translations assignment that you're going to try that's going to let you follow up on our translation ideas. So it's going to let you follow up on your observations from yesterday about what adding and subtracting do to X and Y. And it's also going to let you actually practice translating some shapes on a graph and working with this translation rule outline that we just